In this video, we talk about object-oriented programming or OOP. In Python, we have two programming approaches. The one that we have used so far is known as procedure-oriented programming or POP. In this case, we emphasize a step-by-step execution of procedures. And this means that we usually have a set of functions that perform a specific tasks. But what is very important here to mention in procedural programming is that data and functions are treated as separate entities. This means that data structures are defined separately from the functions that operate on them. Functions are written to perform operations, and they can be called with specific pieces of data as input. To understand this, think of this as a library where you have books or data is stored separately on shelves. And there are various actions or functions you can perform, like borrowing a book, returning a book, or searching for a book. In this case, actions themselves do not belong to any specific book, but can be performed on any book. So that's the main advantage of procedure-oriented programming or POP. On the other hand, for object-oriented programming, which is extremely important in machine learning and data science, we emphasize the organization of code into reusable and self-contained units called objects. And therefore, your program is a collection of interacting objects. And the main advantage here is that data and functions are encapsulated within objects. And in this context, we usually call data as attributes, and we call functions as methods. So this is something very important to remember, that when we talk about object-oriented programming, when we say methods, we actually mean functions. And for attributes, we mean data. Okay, so now with this very brief introduction, let's go and talk a little bit more about components of object-oriented programming. We have two main components. One is class and one is object. So what is a class? A class is a blueprint or template for creating objects. And in this case, you define attributes or data and methods or functions that objects of this class will have. So, right, this is the part that is very important because you encapsulate data and functions inside these objects that you're going to create in the future. And in fact, class acts as a user-defined data type. You have seen even this before when we check the type of integers in Python, you get also something called class integer. So that's exactly what this is about, right? So anything that we work with in Python has a class, which means that somebody has written this class that you can encapsulate attributes and methods. So now that we know what a class is, what is an object? An object is simply an instance of a class, right? So remember, class is the template. Like think about that, you have a template for a Word document file, and now you can actually customize that or instantiate that, right, to send a letter to a very specific person, right? So that, very specific letter now becomes an object. And it possesses unique attributes and behaviors defined by the class, right? So let's start by defining a very simple class to understand better the concept of, attributes and methods and, these topics that we just discussed. One thing that is important is that for class names, it is better that each word to begin with a capital letter. This is what is known as the camel case, right? So for example, we said for functions, it's better to all be lowercase letters, but for class names, it is better to capitalize the first letter in each word. For example, you can have something called my class or car model if you want to write a class that applies to cars. But in this case, let's look at something even more interesting, right? So let's say you want to define a class named student, and this class is supposed to have some important attributes or data, such as a student ID and name, right? So these are two important pieces of information we need to record for each student. And also we want to have one method to just print this information, right? Remember, print is actually a function, right? Because you want to act on something and print. So that's why here we have two attributes and one method which will be printing this information. The most important thing when you write your own class is to know how to use constructor. So what does this mean? So the nice thing about constructor is that once you want to create an object using the class that you have, Python will execute or run this function you have here. It's obviously a function because it starts with def. That's how we define functions, without needing to explicitly call this function, right? So the way that this works, if you look at it, this function has this underscore underscore init underscore underscore. And this tells us that this is a special function. So this is not just any function. This has a very special meaning in Python. And this means that once you have this in a class and you call that class to create an object, then this will be called in the background. And the way that it works is that the first argument should be something called self. I have to say that you don't have to necessarily use the name self, but this is a very good programming practice to use self. And what this does, because remember that right now you are creating a template, right? So you do not have instances of this class. So you have to have a mechanism to refer to this class later on, or this object of this class that you're creating. And in order to do this, you use this term self. And after that, you have your input arguments or attributes, which, as we said, there are two of them here, a student ID and name. So this means that once you use this constructor, you initialize this class with these two attributes. And as we said, self here refers to the instance of the class being created, right? Because we need to do this to make sure that we can refer to this, object that we're going to have in the future. So just to explain how this works, so you start with the class keyword, right? So that means that we want to define a class. You choose the name that you want. Here I use a student, or you can choose any other name. You can follow the camel case rule that we said. Very similar to when we use like if a statement, or even we define functions, you need to use the colon. And remember that here, if I press enter, you see that I have these 4 spaces, what is known as indentation in Python, right? So this means that anything that now has this indentation will be part of this class, right? So if you want to later on have something that is not part of this class, please do remember to remove this space, right? Meaning that you have to, for example, then, start from here and say print something, right? So that's how you know that you are exiting this class definition here. But let's back to where we were. So we defined the class, we used the colon, we used the indentation. And as we said, the first thing is that you need to have your constructor, right? For initialization of your, or instantiation of your class, it's better to say. And in this case, use the def for defining a function. And use this special function, is underscore underscore init underscore underscore. We use self as we said. And then from this point, you have your input arguments. Now we have to assign these arguments to this self. So we create these attributes self dot student ID self dot name. This equal here is the assignment operator, meaning that we want to assign a student ID to self dot student ID and name to self dot name, right? So this self, which is the object being created, now has these two attributes, a student ID and name. And remember, here you should not use parentheses, because parentheses are used to call methods or functions, and attributes, as we said, are essentially data or variables that store data. within an object, and they don't require parentheses. So now that we have this constructor here, let's just add one method or function, something very simple to make sure that our definition of class here works. And we call this display info. And remember, now you have to pass this self, right? Because again, this self now should be passed as input to this function. And we just have two print statements, right? We use the F string that we said before. We say that a student ID is whatever is in this self.student ID, and name is what's included in self.name, right? So we retrieve the information from these two attributes. So we define the class, right? So this means that now we have the template for creating objects, but let's create objects, right? So I create an object called it's called a student1. That's the name of this object. That's the name of the class. And remember, because here in the constructor, we need these two pieces of information, we have to provide a student ID and also name. And once I create this, right, remember that now this object has these two attributes. And I can access these attributes using this dot notation, right? A student1 dot a student ID, a student1 dot name. And as you expect, you can see that we can retrieve this information, right? This is what we provided for this student. So we can always use this dot notation to access attributes, but sometimes it is nicer to have this in a little bit more readable format. So that's why we included that method called display info, right? And I can just now call this. Remember, this is a function. So that's why here you need parentheses, right? This is a method or function. And if I run this, you get exactly what we defined before, right? We said that you need to print a student ID and whatever the student ID is, name, and the name of that object, right? That's consistent with these two print statements that we have here. So this is very interesting, right? So you can access attributes using this dot notation. You can also add methods to be able to also display or print these attributes if you want to. So right now we created one object. Let's create another object, right? So this is the idea of reusability that we mentioned, right? You have this student class and you can create as many objects as you want, right? So you're at the university, there are 20,000 students. You can have 20,000 objects created using this class that we have defined, this blueprint or template. So here we have another student ID. These are just some random numbers, another name. This case, I want to just use the display info, and you can see that now we have the student ID and name for this new student or new object that we have here. But the fact that matters is that you can now add a lot more functionality, right? So that's what we talk about, right? The fact that you can actually encapsulate data and functions within these objects, right? So let's say that this class that you have, you want to add a method called add courses to this class to store the list of courses that a student has taken. This is very important, right? You want to know, whether a student can graduate or not. And for that, you need to make sure that you keep track of all the courses that each student has taken. So how this works is that very similar to before, we use the class keyword, the name of the class. We use the constructor. Remember here, at the beginning, we can assume that the courses that each student has taken is an empty list, right? That's what this is. This is an empty Python list. And we don't even have to provide any input for this, right? Like before, we have a student ID and name, which we assign to each student, but we assume that each student starts with no prior courses. So that's why it's an empty list. We modify the display info to also add the information about the courses that they have been taken. But what's really important here, we need to add a new method or function where we can add courses, right? So again, self should be always included because that's what refers to the object being created. Then we need to add a list of courses that the student has taken. And then self.courses underscore taken is a Python list, right? Remember that that's how we define this. And for a Python list, we can use this dot extend method that you can provide a list of courses, and this will be added to this empty Python list that we have, right? So that's like the main difference here, that we added a new attribute called courses underscore taken. And now we can also update that attribute using this new method, right? So that's the main difference from what we have here and what we had in the previous cell. So like before, we can create a new object or a student with some student ID, some name. You can even right now use the display info. And you can see that since we have not used add courses before, there's no courses available for these students, an empty Python list. But let's say now we use this .add courses method, and you provide a list of courses that this student has taken, right? So mathematics, history, programming, 3 courses. So once you run this first line, you will add this information to that courses underscore taken. And if I use this dot display info, this method that displays information for this student, you can see that now this courses underscore taken is not really empty anymore, right? It has the information that we provided, and we were able to successfully update that attribute, right? But what is even more interesting here, I would say, is that from now on, at any point when this student takes a new course, you can always use this add courses method and keep track of all the courses, right? Because you have a like an attribute, which is a list with these 3 courses here. And now you use this add courses again, and you're going to add the statistics to whatever this student has already taken. And you can see that if I run this again, we have statistics as the 4th course included here. So you can see this idea of encapsulating data and functions, right? Because now we have a very special function, this add courses, which works on this attribute or data, which is called courses taken. And also we can reuse these as many times as we want. If we have 20,000 students, we can use these for all 20,000 students. So to just recap what we had, here's the summary of the main syntax for defining a class in Python. Obviously, use the class keyword, the class name. You always want to have this constructor. This is very important. And the way it works is using this underscore, underscore, init, underscore, underscore. Do not forget to use self. And then use your arguments that are parameters passed during instance creation. And then usually you can update these arguments or these attributes that we have here that we passed using these methods that we define, right? So these are some methods to define behavior of this class. And remember that self refers to the instance calling the method. And that's something that we can always keep in mind in terms of like the main structure for defining classes. Something that is important to remember is that when we talk about attributes, we have instance attributes and class attributes. Instance attributes belong to specific instances of the class, right? Or the objects. And so they're unique to each instance. For example, a student ID that we had, right? Each student has a unique student ID. That's something that belongs to the instances of the student class, not necessarily the entire class. And for those, usually we define them within the constructor method, that init method that we just said, right? But class attributes belong to the entire class and shared by all instances of the class. Let's say that you want to have like a class called like circle. To explain this, we import the math module. And in this case, because we want to use the number pi, right, to like, for example, find the area or circumference, we, define this math.pi, which is included inside this math module as pi. And remember, this is now class attribute, right? Because this belongs to all instances of this class. And we specifically put this outside the constructor, right? So this is our constructor, and we put this pi outside. So this pi now on is something that is shared across all these instances. But obviously something like radius is a specific to that object or that circle that we have, right? So we don't want to share the same radius across all of them. That's why it's inside this constructor. And so you can now use, let's say, one method, which is called calculate area, right? So pi r squared, that's exactly what we have here. But the way that we now access this pi, remember, this is a class attribute. The class name is circle. So you say circle, the name of the class, dot pi, right? So that has now a very special meaning, means that that's the pi that we have in math, right? And then obviously you have the self dot radius because this is something that belongs to the very specific instance of this class, right? So that's why here we have self dot radius and then the class name dot pi, right? One is class attribute and the other one is instance attribute. You can also calculate, circumference is 2 pi r, right? So, but just to show you the fact that you can use this class attribute using this name of this class dot pi. And, now we can create different instances or objects. So you just have to call the name of the class and then the radius, because that's the only thing that we really need here, right? That's just the radius. And now you can see that we can access these class attributes or use this calculate area or calculate circumference, and you can print this information, right? So you can see that this circle.pi is 3.14.1415, right? So that's the pi that we have. And then we have the area of circle 1 and the circumference of circle 2, right? So you can always double check to make sure that these are correct, but I'm sure we have done everything here correctly. Okay, so now let's go to the next topic. In Python, if you use the name of object and then use the dot notation and then underscore underscore dict and then underscore underscore, this is a dictionary that holds the attributes and object, right? So let's say we have this class example. I want to make it really simple, where we have two information or two attributes, I would say, name and age. So now we have to just assign these to these attributes. Usually you want to add also some methods to do something with these attributes, but right now we want to keep this simple. And you can see that if I use this, name of this object, which is, obj dot this, keyword that we said, this dict here that we have, you can see that you can now get a dictionary, right? To just show that this is actually a dictionary, you can use the type function in Python that works everywhere. So this is indeed a dictionary. And you can see that the name is John and age is 25, right? So these are the key value pairs that we have. Okay, so now let's move on to the last example that we have in this notebook. And this is something that very much related to when we do what we want to do in data science and machine learning. So let's say you want to have a basic implementation of a custom array. So, for example, Python list, NumPy arrays. But let's say now you want to have a custom array that mimics some of the functionalities of a NumPy array, but focusing on Python list with attribute n, right, where n represents the length, along with some basic operations such as dot product or vector norm that we want to implement, right? So obviously you can use like NumPy arrays to perform this, but right now we want to have our own class that has a very special like functionality, right? Without really going through a NumPy array, right? So the goal here is that, create a custom array that kind of looks like NumPy array, but not necessarily using built-in functions in NumPy. And in order to do this, we're going to start with math module. Remember, math module is something that is included in Python. So it's very helpful for any kind of mathematical operations. We have been using this even before introducing NumPy arrays. So in this case, we define a class called custom array. Remember that we use uppercase letters for the first letter of each word. Obviously, in this case, you want to have, again, your constructor, and it starts with this init. Self is always there. Again, it refers to the object of the class being created, and then some data, right? So something that is very nice here, you can actually use this isInstance method or function in Python. And we have used this before. Just to recall this, you have two arguments. First, you provide your object, and then the type that object you want to see whether it belongs to or not. So we want to make sure that here, this custom array that we have, we provide a Python list. So we say that if not isInstance data of type list, then raise some error, right? So we have not discussed this in much details before, but what this does is that we check this if statement, and if the input is not a Python list, then we raise this error, which says that input data must be a list. And now, if actually the input is a Python list, now we use this self.data, which is the data that we provided. So that's the attribute that we call it data. And then the other attribute that we want to have here is this n, which is simply the length or the number of elements in this Python list, right? So we want to have these two attributes defined. And then we want to perform some operations on these Python lists. And one of them is, for example, like dot product, right? So if you have two Python lists and you want to find the dot product between them, you're going to multiply the corresponding elements and then add the result of these, products, right? So the first thing you want to do is that if we have two Python lists, so one is self, which is what we have here, and then also we need the other Python list. Obviously, you don't have to call this other, but that these are good programming practices. That self refers to the current object that you have or you want to create, and the other corresponds to the other object, which is another Python list. And if these two, because now we have this attribute which is called n, which is the length of this, if the lengths of these two arrays are not equal, we cannot find dot product. So we have to provide some error message that we have done here, right? So you provide this value error to say that input arrays must have the same length, so the user knows that what happened and why an error message is encountered. But if they have the same length, then what you can do is to use this zip, which is something again we discussed before. And what this does is that if we have two lists here, right, we have self.data and other.data. So these are the two Python lists. You're gonna create a list of tuples where each tuple contains one element from the first list and one element in the corresponding location from the second list, right? And so now you can use this for loop to iterate over all these pairs of values, and then you're going to multiply them together, and later you're going to sum all of them, right? So these are the ideas that we had behind list comprehension, right? So obviously you can write this in multiple lines, but it's a much more compact way of doing this. So you use this zip to create a list of tuples. You use this for loop to iterate over the elements of these tuples. You multiply them together, right? And then finally, you're going to sum them together. So one thing you can do if you're not 100% sure how this works, create two Python lists and call one call one self.data and the other one other.data. So these are the two Python lists that you have. And just perform this, right? Use the zip and then the for loop and then multiplication and then the summation. And in that case, that should really makes sense. And then also we can here create another method, which is this vector norm. And then you have this self again here. So for vector norm, remember, you just want to find the norm of a vector. So we only have one vector. We do not have the other one that we used before. And this one is also simple, right? So for each element in that list that you have, you want to raise that to the power of 2, add all those values, and then take the square root, right? So that's the definition of the vector norm, right? Which is the square of each element. You add all of them together, and then you take the square root. So in this case, let's say that we have a custom array where you pass your list, which is this 1, 2, 3, and then you have another object, which is this array 2. You pass in 4, 5, 6. They obviously have the same length. They're both Python lists, so we don't expect to get any error messages. And now the way that you can use this is that you can say for dot product, finding the dot product, you have array 1 dot product. That's the name of this method. And now you provide the other list or object that we have, which is this array 2, right? And then for using this vector norm, you can see that we can just use array1.vector norm. And this doesn't really need any input right now, right? Because the only input is self, which is already provided. And it will automatically find what we need here, which is this sum of the square of elements, and then taking the square root, right? So if we do this, you can see that we get the dot product, which is 32, and then the vector norm. So something that we can actually do here to just show you how this zip works here in this case, that's something important. So let's look at this very simple example. Here I'm going to work with 2 Python lists. So I call list 1, and I'm going to copy this 1, 2, 3, and I'm going to have list 2, which is going to be 4, 5, and 6. Right. So just to show you what this zip does here, I can just copy that. And remember, right now, list 1 is what we have here, and we have list 2. So I'm copying pasting so you see like exactly how that works. And in order to see what's actually included inside this zip, we can use list. And if I run this, so this is exactly the idea behind using this zip, right? So you get a list of tuples where each tuple has 2 elements, one from the first list, one from the second list, and you can do this for all other elements that you have or other positions that you have, 2 and 5, 3 and 6, right? So in order to find the dot product, you want to multiply these 1 and 4, 2 and 5, 3 and 6, and then add the result, right? So that's exactly what we have here. So I can show you this part of this. Let's show you this one. So we can remove that here. So now we have that for X and Y, right? So X corresponds to the first one, Y corresponds to the second one. In zip of list 1 and list 2, we want to find this sum of these elements. So this should give me that 32 that we have seen before. So let's run this and see what we get here. And that's exactly what we see, right? So what's happening, you multiply 1 and 4, which you get 4, 2 and 5, which is 10. So far we are at 14, and then plus 3 times 6, which is 18. So 14 plus 18 is 32, right? So that's just something that we're going to need also for the homework problems too, using this zip to be able to perform these element-wise operations. Okay, so let's see if we get an error message. And going back to this class that we defined, right? So if you remember, we said that we need to provide a list. But what if we provide a tuple to this custom array? Do we get an error message? Of course we do. So if you see that we get this type error, input data must be a list. And this comes from actually this if statement that we have, right? Because now if we choose the is instance, right, that tuple is not a list, so that's false. And then there is a not here, which makes it true. And so this means that you're gonna raise an error and you're gonna exit this sort of like, object creation here. So, and you will explain what the problem is. And let's look at the other error message that we included. What if we have two objects with different lengths? If I use the dot product, you again see that it says value error, input arrays must have the same length. So this is the error message that we included. And obviously you can check the instance attributes here that we have. So you can see that array one, if you use this dot n, and remember, we do not need to use parentheses because these are attributes. We get 3. And so this wraps up this lecture on classes, objects. As you see, they're very simple topics once you get to create your own classes and objects and start working with them. So that's something important to start experimenting with the code that we have here. Okay, so in terms of homework for this problem, we want to use this custom array that we have here for the problem 1. So we have already this custom array, right, where you have a Python list, and then you define the dot product, vector norm. But what we want to do here to make this even more interesting and add some more tools from statistics. For example, one of them is this correlation coefficient between two vectors or two Python lists, to better say here, where the formula is, basically a summation of xi minus x bar, and x bar is just the mean of the first vector x, y bar is the mean of the second vector. So it's very much like an element-wise operation as we just did for dot product, except that now you have to subtract these means from both vectors. And then for the denominator, if you look at it, it's very similar to that, the sum of the squares that we had before, except that now, again, you have to subtract these mean vectors from both of these summations. So that's one method or function we want to add, this Pearson correlation. The other one is the vector norm. And so what you can do here is that we have something known as LP norm, which is very helpful in machine learning and data science. So this is a general norm where the way you calculate this for a vector, you raise each element to the power of p, and then you add them together and raise it to the power of 1 over p. So if p equals 2, this is exactly the norm that we already implemented, the vector norm, also known as the Euclidean norm. But it really here is interesting that this p can be any number greater than 1. So, it can be 1, it can be 3, 4, 5. So it can be anything greater than or equal to 1. And we want to give the user, when we define this function, the flexibility to use any p that the user wants, right? So you can see that here for solving this problem, we copied paste part of the class definition that we had, but here you have this Pearson correlation. And remember, here you want to find this between two lists or vectors. So you need to have self and other, very similar to when you find dot product. I've included a statement here to raise an error if we do not have the same length right before. And here is where you have to add your code, right? So this is where you include your solution. Similarly with LP norm, right? So here you also have this P. And the only thing that here we want to make sure is that P is not less than 0 or exactly 0. But, in terms of, we're going to talk about this later on, to be a valid norm in the sense that we define in mathematics, it has to be actually greater than 1, not necessarily greater than 0. But computationally right now, you can actually find this value for any p greater than 0. So that's why we have just that statement. And for any p greater than 0, you can, raise these xi's to the power of p, and then the whole thing raised to the power of 1 over p. And you should be able to use everything from the math module. So remember here, the goal is not to use NumPy's built-in functions or methods. We want to have our own custom array. And I included one test case that you should run here to make sure that your code actually working properly. So once you define your class, you can run this cell. The other problem that we have here is very interesting. It's actually a gateway to data science and machine learning. So what we know right now, it actually you can implement your own linear regression class or model. We are going to talk about machine learning libraries and data science libraries later on. But right now, you can actually create your own small libraries in some sense. So in linear regression, the equation that we have is that, the dependent variable or output is beta 0 plus beta 1 times x, and x is your independent variable or input, right? So we know that beta 0 is technically the intercept or the y-intercept, and beta 1 is the slope or the coefficient, right? That's what we learned in calculus 1. And so if I give you a bunch of data points, meaning that multiple instances of x and y, like x1, y1, x2, y2, right? So different data points that belong to this equation, you can actually, calculate or estimate these coefficients using these formulas, right? It looks kind of like that Pearson correlation coefficient that we have with some, minor modifications, right? And these bars here means that these are the means of the vector x and means of vector y. So we're going to go later through why we have these two equations here. But right now, because we are mainly focusing on programming and object-oriented programming in particular, we want to be able to just implement this. So you want to define a class and then create these methods to calculate these coefficients. And once you have this beta 0 and beta 1, now for a new input like this new x, you can actually calculate this output, which is this y, right? So beta 0 plus beta 1 times this new input. So that's when you want to make predictions. So here we have, the basics of this class linear regression. For simplicity, here I included some information, and now we have these two: calculate coefficients and predict. And you can see that here we have one example where I already know this beta 0 and beta 1. That's how I created my data. But I want to make sure that you run this class and create these objects and find beta 0 and beta 1 to make sure that this works. And then later on, you want to define a new class called NumPy Dataset Analyzer. In this case, you're actually working with 2D NumPy arrays, right? So that in that case, actually your input is a NumPy array. But what you want to do is to add these methods or functions to really simplify the process, such as like calculating the mean for one column, median, finding the minimum, and finding the maximum value. So we already know how to do this in NumPy. The only thing we really want to do is to put this in a class definition where it's specialized to be able to find these different values for each column.